Hello friends, today we will discuss exercise 1.4 of CBSE class 10 real numbers. So last video we have discussed the three theorems, theorem 1.5, 1.6 and 1.7. What theorem 1.5 says, if x is a rational number and if it is terminating type, then x is equal to p by q, means q will have the form 2 raised to n into 5 raised to m. That is, if x is a rational number and if it is terminating, then the denominator will be of the form 2 raised to n into 5 raised to m. What is theorem 1.6 says? That is the reverse of this. If x is a rational number and if the denominator is of the form 2 raised to n into 5 raised to m, then it will be terminating. What is theorem 1.7 says? If x is a rational number and if the denominator is not of the form 2 raised to n into 5 raised to m, then the decimal expansion is non-terminating but recurring. Yes. So 1.5 says if it is terminating, then it is of the form 2 raised to n into 5 raised to m. 1.6 says if it is 2 raised to n into 5 raised to m, then it is terminating. 1.7 says if for a rational number x, the denominator is not following the pattern 2 raised to n into 5 raised to m, then the decimal expression will be non-terminating but recurring. Okay, with this background we are coming to exercise 1.4. Without actually performing the long division, state whether the following rational numbers will have a terminating decimal expression or a non-terminating repeating decimal expansion. Okay, question number 13 divided by 3125. So 13 divided by 3125 is equal to 3125. We can factorize 5, 6, 25, then 5, 1, 2, 5, 5, 25, again 5 and 5. So this is equal to 13 divided by 5 raised to 5. So this is of the form 2 raised to n into 5 raised to m. Here 2 raised to n is equal to 0 here. So this is terminating. Second one, 17 divided by 8 equal to 17 divided by 2 raised to 3. Again it is of the form 2 raised to n into 5 raised to m, where m is equal to 0. 0 is allowed. So this is terminate. 3. 64 divided by 455. 64 divided by 455, we are factorizing 591. So 64 divided by 5 into 91. Here 2 raised to n is equal to 0, 5 raised to m is equal to 1, but there is one extra factor, that is 91. So if the denominator is not of the form 2 raised to n into 5 raised to m, then it will be non-terminating but recurring. This is also a prime number, but it is of the form non-terminating and recurring. This is as per theorem 1.7. Now fourth question, we will move a little fast. We have to complete this in this video. So 15 divided by 1600 is equal to 3 into 5 divided by 1600 can be written as 5 into 320. Why I am writing 5 into 320? Because I have a numerator in 5. I have a numerator 5. So I have to cut this because I have to reduce this to lowest form before concluding. So this is equal to 3 divided by 320. Now we will be factorizing 160, 280, 240, 220, 210, then 25. So how many 2's are there? 6 2's are there. So this is equal to 3 divided by 5 into 2 raised to 6. Again, this is of the form 2 raised to n into 5 raised to m, where n is equal to 6 and m is equal to 1 here. So this is terminating. Now fifth question. 29 divided by 343. 29 we know it is a prime number. 343 can be written as 343 we can factorize with 3 is not a factor, 7, yes. So 7, 49, 7 and 7. So 7 raised to 3. So this is not of the form 2 raised to n into 5 raised to m, but it is a rational number. So it is non-terminating but recurring. Now sixth one. 23 divided by 2 raised to 3 into 5 raised to 2. Yeah, clearly 23 is a prime number here, and the new denominator is of the form 2 raised to n into 5 raised to m. So this is clearly terminating. 7. 129 divided by 2 raised to 2 into 5 raised to 7 into 7 raised to 5. 129 is not a factor, is not having a factor 7. 129 is not having a factor 7. Anyway, this is having 7 raised to 5. So this is not going to be cut off with the numerator. So some 7 will definitely remaining in the denominator. Hence this is of the form 2 raised to n into 5 raised to m into some other number. So definitely as per theorem 1.7, this is non-terminating and recurring. Eighth question. 6 divided by 15. 6 divided by 15 can be reduced to 2 divided by 5 into 3. So that is 2 divided by 5. Again it is of the form 2 raised to n into 5 raised to m. So it is terminating. Ninth one. 35 divided by 50 can be written as 35 divided by 2 into 5 into 5 is equal to 7 into 5 divided by 2 into 5 into 5 is equal to 7 divided by 2 into 5. Again it is of the form 2 raised to n into 5 raised to m, so terminating. Now 10th question. 77 divided by 210 is equal to 7 into 11 divided by 7 into 30. So 7 is getting cancelled here. We are getting 11 by 30. So this is equal to 11 divided by 3 into 2 into 5. 2 raised to n into 5 raised to m is there, but one extra fellow is here, 3. So here it is non-terminating but recurring as per theorem 1.7. Okay, now question number 2. Write down the decimal expansion of those rational numbers in question 1 above which have terminating decimal expansions. Write down decimal expansions of those rational numbers which have terminal. Okay, so we have to consider only terminating cases. We have to consider only terminating cases of this. So we have this one, again this one, then here terminating. So all these cases we have to take, and we have to find the decimal expansion. So we will take one by one. So first one is 13 divided by 5 raised to 5. So 13 divided by 5 raised to 5 can be written as 13 divided by 5 raised to 5 into 2 to the power of 5. So again 2 power 5. So this is equal to 13 into 2 to the power of 5 is equal to 32 divided by 5 into 2, 10 raised to 5. So that is equal to 13 into 32, that is 416, divided by 10 raised to 5 is equal to 0.00416. Okay, now second question. 17 into 5 cube divided by 2 cube into 5 cube, that is equal to 17 into 125 divided by 2 cube into 5 cube is equal to 2125 divided by 2 into 5, 10 raised to 3 is equal to 2.125. Now we have fourth question terminating 3 by 320. So this can be written as 3 divided by 5 into 64 is equal to 2 raised to 6. So this is equal to 3 into 5 raised to 5 I have to add, because here only one 5 is here and there are 6 2's. So I have to match this and this. So I have to multiply with the 5 raised to 5. When I multiply denominator, I have to multiply the numerator also. So that is why I am multiplying 3 with the 5 to the power of 5. So this 5 to the power of 5 will become 5 to the power of 6 into 2 raised to 6. So this is equal to 3 into 3125 divided by 5 into 2, 10 to the power of 6. So that is equal to 9375 divided by 100, how many zeros? 6. So that is equal to 0.009375. Okay, now fourth is over. Now sixth one, 23 divided by 2 raised to 3 into 5 raised to 2. 23 divided by 2 raised to 3 into 5 raised to 2 is equal to, here we have 3 2's but only 2 5's. So we have to multiply with 1 5 here, so that the denominator becomes 2 raised to 3 into 5 raised to 3. Yes. So this is equal to 23 into 15. 23 into 15 equal to 115 divided by 10 raised to 3 is equal to 0.115. Okay, now 6 is over. Now next terminating case is 8th. 2 divided by 5, simple one. Here we have only 1 5, so we have to match. So we have to add 1 2 also. So 2 into 2 divided by 5 into 2, that is equal to 4 divided by 10 is equal to 0.4. Then which is the next terminating case here? Yes, 9th one. 7 divided by 2 into 5. 7 divided by 2 into 5. 7 divided by 2 into 5. This denominator is already in the form of 2 raised to n into 5 raised to m. So this is equal to 7 divided by 10 is equal to 0.7. Okay, now we are going to question number 3 of exercise 1.4. The following real numbers have decimal expansions as given below. In each case, decide whether they are rational or not. If they are rational and of the form P by Q, what can you say about the prime factors of Q? Okay. Following real numbers have decimal expansion as given below. So we are given a decimal expansion. We have to decide whether they are rational or not. If they are rational, what we can say about Q? That is the question. Okay. So 3, 1. Question is 43.12345678 9. This is clear case of terminating. So when it is terminating, the denominator will be of the form 2 raised to n into 5 raised to m. So that is the answer. So Q is equal to 2 raised to n by 2 raised to n into 5 raised to m. Second case, 0.120 1200 12000 124 times 0, like that. This is non-terminating and this is non-recurring also, because here it is 120, here it is 1200. This is not allowed. It should be recurring, means it should be same. So this is non-terminating and non-recurring. Non-terminating, non-recurring means it is an irrational number. It is not a rational number. Now third question. 43.12345678 all these repeating. This bar means all these repeating. So 43.12345678 123456789, like that it is going. That means it is non-terminating and recurring. So it is a rational number which is non-terminating and recurring. Okay, now we have completed exercise 1.4 of chapter 1. If you require any clarification, you can go through my previous videos. So in the next videos we will go to the next chapters. Thank you.